Okay, so picture this. A natural disaster hits. Everything's chaos, right? In those first critical hours, what's the most powerful tool you have? It's not a helicopter, it's not a rescue boat, it's information. And today, we're going to see how just a few lines of code can turn raw data into a map that shows first responders exactly where to go. A map that can literally save lives. So that's the big question, isn't it? Because when you're in the middle of a crisis, clarity is everything. A good map can be the difference between getting supplies to a stranded community or not. So let's get our hands dirty and actually build one.
All right, here's our mission. A cyclone has just slammed into the coast of Bangladesh. It's an urgent, life-or-death situation, and the people on the ground need a map to figure out just how bad the damage is. And they need it now. Now, this isn't just a drill. It's a huge public health challenge. We're talking about millions of people at risk. Responders have to find them, they have to plan where to send aid, and they desperately need to know the size of the flooded area. The map we're about to create, that's going to be their guide through the chaos.
Every map has to start somewhere. For us, it's basically a blank screen. But you'll be surprised how, with just a couple of simple commands, we can start to bring the shape of an entire country into view.
And this is where it starts. It looks almost too simple, right? We're using a programming language called R. That first line just loads a package that has all the geographic data for Bangladesh. And the second line? Well, that's pretty much just telling the computer, hey, draw me a map of the country's main regions. That's it.
And boom, there it is. Just like that, a shape we can recognize pops up. Yeah, it's just a bare outline for now. It's kind of like a skeleton. But this is the foundation we're about to build everything on. So we have a shape. But a map is totally useless if people can't understand it. And in a crisis, nobody has time to solve a puzzle. The map has to get its point across instantly.
This all boils down to a really important design idea called visual hierarchy. Think about it. When you glance at a map in an emergency, your eyes have to go to the most critical info first. That's the map itself, the title that tells you what you're looking at, and the legend that explains what the colors and symbols mean. Everything else, like a scale bar or a north arrow, that stuff's secondary.
So we're going to apply that idea step by step. First, let's add some color so we can tell the different regions apart. Next, a clear title so there's no confusion. And finally, some labels so we know the name of each area. See, already it's 100 times more useful.
You know, there are some simple rules that make a huge difference here. You want to keep the number of colors down, it just makes things less noisy. But check out this detail about the fonts. You use a clean, modern-looking font that's sans serif for things humans built, like cities, and you use a more classic-looking font, a serif font, for natural things, like rivers. It's a tiny detail, but it's a clever little trick that helps our brains sort through the information way faster.
Okay, so our map looks good, it's readable, but now we're at a crossroads, a really crucial technical choice that can either make this map a lifesaver or pretty much useless. And it's all about something called the coordinate system. This is the key term you need to know. Coordinate Reference System, or CRS for short. The easiest way to think about it is, it's the language the map uses to connect the picture on your screen to an actual spot on planet Earth.
Now, there are basically two main types of this language. The first one is the one we all know from our phones, GPS, latitude and longitude. It's awesome for pinpointing a single location, like the hospital is right here. But the second type, a local grid, pretends the world is flat, like a piece of graph paper. And that makes it absolutely perfect for measuring things, like how big a flood zone is or how far an ambulance needs to drive.
So if you only remember one thing, make it this. GPS helps you find the place. A local grid helps you measure the place. Super simple. And for our cyclone mission, we need to know how big the flooded area is. We need to measure. So you guessed it, we absolutely need that local grid system.
And here's what that looks like in the code. Most data, by default, is in that GPS format, which has a special code 4326. But for our mission, we have to switch it. We're going to use something called a UTM grid. The one for Bangladesh is code 32646, and it's specifically designed to give us super accurate distance measurements for that part of the world.
And you won't believe this, but it takes just one line of code. This one command, st-transform, switches our entire map from the finding system to the measuring system. It's such a small step in the code, but for the responders on the ground, it's a massive leap in how useful this map is. All right, we've got our design rules down, we've made the critical decision about our coordinate system. Now it's time to put it all together and build the final map that's actually going to help guide the emergency response. So this last block of code is the whole recipe. First, it zooms in on just the 2 districts hit hardest by the storm, Khulna and Satkhira. Then it does that all-important switch to the right coordinate system for measuring. And finally, it styles the map to make those emergency areas jump off the screen in a bright, unmistakable red.
And this is why we did all this. This map isn't just a pretty picture, it's a plan of attack. It shows responders exactly where to go, it helps them spot potential health disasters like contaminated water, and lets them figure out the smartest places to set up clinics and drop off aid. And here it is, the final product. We started with nothing, and with just a few lines of code and a couple of key choices, we've made a clear, simple, powerful tool. The gray areas give you context, but those red zones, they're screaming for attention. This is a map that demands action. This map is an incredible start. It answers that vital question of where. But just think about the possibilities for a second. What if we added another layer of data showing where the hospitals are, or population density, or which roads are still open? Suddenly, a simple map becomes the central nervous system for the entire response. And that, right there, is the real power of turning data into something people can see and use.